So back when we were talking about horizontal asymptotes and how to figure out where they are going to be located, we said that if the degree of the numerator polynomial is greater, if it exceeds the degree of the denominator polynomial, then we will not have a horizontal asymptote. But there is another type of asymptote that we might have, and we're going to look at that right now. So if the degree of the numerator, so we'll call that p of x, if our general layout of a rational function is p of x over q of x, if the degree of the numerator is exactly one more than the degree of the denominator, then we will not have a horizontal asymptote. The degree of the numerator is larger, but we will have what's called a slant asymptote. Now, a slant asymptote will be a line, but it's no longer going to be horizontal. Now, I'll use the term slant because it's a little bit shorter to write and to say than oblique, but the technical name for these types of asymptotes is oblique asymptotes. All right. Now, the way that we find the equation of this oblique asymptote to actually figure out where it is and eventually graph it and use it to constrain our rational functions graph, to find what we are going to do is perform the division. So we will divide p of x, our numerator polynomial, by q of x. The slant asymptote will be the quotient. So let me show you an example by way of explaining what all of that means. Suppose we are working with a rational function, x squared minus 6x minus 7 over x minus 1. So we'll get a little bit of practice finding a vertical asymptote first. Alright, so we would like to reduce our function down. So I want to see, can this thing factor? Well, my numerator can factor as x minus 7, x plus 1, and my denominator is x minus 1. So I notice that nothing can cancel, and I can then take the denominator, set that equal to 0, and that will tell me my vertical asymptote, and only 1 this time, is at x equals 1. So now we'll look at the other types. I notice that the degree of the numerator is 2, the degree of the denominator is 1, so we're in that special case where we won't have a horizontal asymptote, but we will have a slant asymptote. That's always going to be the case when the degree of the numerator is 1 more than the degree of the denominator. So let's find the slant asymptote. And to do that, I am going to divide x squared minus 6x minus 7 by the denominator polynomial x minus 1. Now I could use long division, but since this is a linear factor, I can actually use synthetic division. So I'll put 1 in the box, and I'll bring all my coefficients down from my dividend. So 1 for x squared, -6 for x, and -7. And I'll bring down the 1, multiply. I'll add, multiply, and add, getting a remainder of -12. Alright, so we've got our remainder and our quotient. So our slant asymptote is going to be y equals x minus 5. So make sure you're very familiar with graphing lines that have slope, as well as the horizontal and vertical lines that we've encountered so far in this section. We are going to need to be able to show what that looks like. Our graph of the function under consideration, the rational function, is going to depend on the shape of this slant asymptote to some degree. So we now have 4 cases to worry about. If our numerator's degree is less than the degree of the denominator, then we have y equals 0 as our horizontal asymptote. If they are equal in degree, then we need to look at the ratio of the coefficients. So whatever the coefficients are, I think we called it a sub m over b sub n, the coefficients of the leading term. Now we have this additional special case. If m is exactly 1 more than n, then we have a slant asymptote, and we need to perform either long or synthetic division of polynomials to find its equation. And beyond that, we will not talk about any of the other cases, what the graphs of those would look like. So those are the 3 that you're going to need to worry about in terms of actually finding an asymptote other than the vertical asymptote. There's a summary of all of this information on page 656 of your text. So check that out and keep that all in mind when we get into graphing these rational functions in the next few videos.